Hello, 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 everybody, and welcome back for question number 17 on our Fermat paper. The five sides of a regular pentagon are all equal in length. Also, all interior angles of the pentagon have the same measure. They're not telling us what it is. You might know it's 108 degrees, or we can work that out. In the diagram, PQRST is a regular pentagon, and triangle PUT is equilateral, so it's got the same length. Also, everywhere we see the same length. And while we're talking about angles, just for a moment, inside an equilateral triangle, we've got 60 degrees. Okay, that one's a very common one. You might not know the 108 one. We'll talk about that in a moment. The measure of obtuse angle QUS. Ooh, that's an interesting one. Is. Okay, QUS, that's what we're looking at here. So what can we do? Okay, so the first thing actually I want to talk about, imagine you had a regular N-gon. I don't know how many sides, but N sides. So it could be 3, and then you're looking at a regular triangle. Could be 5, you're looking at a regular pentagon, any sort of thing. Now, because of the regularity, you get a whole lot of symmetry. If we extend each of the angles out, each of the sides out a little bit, we get these angles in here. Now these are all going to be the same angle. Again, this is because you've got a massive amount of symmetry. The whole thing is rotate a regular pentagon, and you still get a regular pentagon. So all these angles here are the same. But look at what's happening. If we sort of start here, to get to our next side, we rotate by this angle, whatever it is, and it's going to be the same angle everywhere, as I say. And then we rotate again, and we just keep rotating by this angle all the way around until we finally rotate it by the nth time, because it's going to be n of these, and then suddenly we are facing the same direction we started the first time at the sort of the start. So what does that tell me? It tells me n thetas gives me one rotation around a circle. So this exterior angle here is going to be 360 over n, whatever n is. It's 120 if you're looking at a triangle. It's 75 if you're looking at a pentagon. Okay? So now the interior angle of an n-gon, well, we know in total this line would be 180. The interior angle is 180 minus this exterior theta. So the interior angle of a regular n-gon is 180 minus 360 over n. Okay? And so you can use this to figure out that the interior angle of a square is 90, or 60 degrees for an equilateral triangle, or the 108 in this particular question. Okay? So that's a little sort of fun fact there. That's how you can find the internal angles of an octagon being 135. That sort of stuff. Okay, so we can use that. Now, let's get to the actual question. I'll draw sort of a pentagon, a regular pentagon, and we've got our equilateral triangle here. So I will put U here. It was Q, S, so this must be R, this must be T, and this must be P. So we have some 60 degrees is here. Now this full angle here should be 108. So out here should be 48. Similarly, we'll get a 48 out of here, 60 here, 60 here. Okay. Now, we know that all these lengths that I see are the same, other than these two lengths that we add in to make the angle that they're asking me about. They want QUS here. But since all these lengths are the same, look at that. We've got a nice little equilateral triangle here. And there's not equilateral, isosceles triangle. And so the angles opposite the equal sides are themselves equal. So I know 2 dots plus 48 must be 180. If I subtract from both sides, you'll get 132 is 2 times the dot. And so this dot angle, whatever it is, well, it turns out to be 66. A nice little 66 there. So we get 66 degrees. In here, and in here, and in here, and look at that. We got a 60 here, 66, 66 here. Okay, And so what's left? Well, our blue angle. Yeah, our blue angle is what's left over. So, what left over from what, I guess? Well, around this point, we should have a full 360 degrees. So 360 degrees is, well, let's do it this way. Take away the 60 degrees from the equilateral triangle. Take away one of the 66s over on the side here. Take another one of the 66s away. And you should be left with our final answer, this angle right here. So 360 minus 60, that's going to be 300. Minus 266s, well, we know what 266s are. So we'll get 300 minus 132, and that should be 168 degrees. So that should be our angle out here, and that is certainly an obtuse angle. All right. So 168, do I see that anywhere? Yes, right there. Answer B. And there we go. Okay, so that's question 17. Let's get ready for question number 18, and I'll see you for that next time.